Hey kids, Flexing Teacher Weber here. I hope you're having a good day. We've now done one-step equations, two-step equations. Now our last step is to go into a little bit more complicated equations. But before we do that, we're going to have to look at something called like terms in algebra. Now this is actually something we've addressed a little bit already, but we're going to address it a little more formally today. So let's look at this, figure out what these things are with a problem. It says Blaine has 2 apples and Elwin has 3 oranges. Gabby has 4 apples and Martina has 7 oranges. Let x equal apples and y equal oranges. And it says in the first part, write an algebra expression for this situation. Well, okay. So x is apples and Blaine has 2 of them, so I'm going to write x plus x. Those are Blaine's apples. Okay, and then Elwin has 3 oranges, so I'm going to write plus y plus y plus y because he has 3 oranges. And then it says Gabby has 4 apples, so I'm going to write 4 x's plus x plus x plus x plus x. And then it says Martina has 7 oranges, so I'm going to write 7 y's plus y plus y, that's 3 of them, 4, 5, 6, 7. So look at all that. There's an algebra expression for this situation. Now, there's got to be a simpler way to write this. So what we're going to do is let's combine all of our apples and combine all of our oranges. So Blaine had 2 apples or 2x, and Gabby had 4 apples or 4x. So why don't we say 2x plus 4x. And then Elwin had 3 oranges, so let's call that 3y. And Martina had 7 oranges, so let's call that 7y. Now, we can simplify this even further. We can say that 2x plus 4x is 6x, so 6 apples, and 3y plus 7y is 10y for 10 oranges. And we know this thing, of course, as a math expression. It's an algebra expression. And that's as simple as you can get this expression. You can't combine it any further. And we called what we just did combining like terms. To simplify this situation, we combine like terms. Like terms are terms that have the same variable part. So when I'm talking about the variable part, I'm talking about the same unknown number, the same x or the same y. So we can only combine terms that have the same variable part. And I put that in bold there. We can only combine terms that have the same variable part. Now, this whole thing is called the expression. When I'm talking about the 6x, that's called, and that's actually a positive 6x, we call that a term, right? And the positive 10y, when we're just talking about one of these pieces of the expression, we call those things terms. Okay, so the positive 6x and the positive 10y are called terms. And then, of course, we know that the x, just the x and the y, the unknown numbers, are called variables. So it's important we remember that terminology, right? The whole thing is called an expression. The parts of it, like the plus 6y and the plus 6x and the plus 10y, are called terms. And then the x and y of those are called variables. And we can only combine terms that have the same variable part. So that's as simple as we can make that expression. Unless we end up knowing values for x and y, then we could simplify this expression. Let's do some more work with like terms. So we're going to simplify. The first one we're going to simplify is x plus x. Now remember, if there's no number in front of the x, if there's no, we call a coefficient in front of the variable, then there is one there. There's a 1, right? So think of that as 1x and 1x. And if we want to simplify this, we could simplify it to 2x. And then just a reminder, I guess for more terminology, we call that number in front of the variable, we call it the coefficient. Forgot to mention that on the previous slide. And that's as simple as we can take this unless we know a value for x. So number 2, 1x, 1x, 1x. To simplify that, we say that that is 3x. That's as simple as we can make it. Or this one here, we have 2x plus 3x. We add up those parts because they have the same variable. And we say that's 5x. And that's as simple as we can make it. So that's what it means to simplify like terms. We combine terms that have the same variable part. And remember, in the question like number 3, we call positive 2x and positive 3x a term. The x's are called variables, and the number in front of that x is called the coefficient. Okay, we'll get a little more complicated. So we have 4c plus 7f plus 6c plus 8f. And remember, we can only combine terms that have the same variable part. So in number 4, we can combine 4c and 6c. And I want to stress that treat these like integers. Whatever sign is in front of the term goes with that term. So this is positive 6c, and this is a positive 4c. So that makes 10c. Do you see? Meh. And then we have a positive 7f and a positive 8f. You combine those together, and you have positive 15f. And that's as simple as we can make this because c and f are different variable parts, and we can't combine terms that have different variables. Now, in number 5, I've got a 2h. I've got a negative, this is, remember, 1h. And I've got a positive 6t and a negative 7t. Now remember, the sign in front of the term goes with the term. So this is like positive 2h, negative 1h. You combine those, you have positive 1h, or just h. And then for the t's, you have a positive 6t and a negative 7t. The signs are different, so you subtract them, and you have a negative 1t. And this could also be written as just h minus t. They mean the same thing. Okay, so that's how we combine like terms. Treat them just like integers. Let's look at another one, a little more complicated. So number 6, we have a negative 4x and a negative 1x. Well, negative 4x, negative 1x, the signs are the same. So you add them, you get 5x, but they share that negative sign, so it's negative 5x. And this is positive 2y and negative 5y. The signs are different, so you subtract 5 minus 2, which is negative 3y, because you have more negatives than positives. So as simple as they can get, this is negative 5x and negative 3y. You can't combine terms that have a different variable part. And we don't see these very much in grade 8, but in number 7 we have a variable that has a squared on it. But that just indicates that this x squared is different than x. So when we go to combine the like terms, Well, we have a negative 5x squared and a positive 3x squared. X squared is different than x, so we can only combine this one and this one. The signs are different, so I subtract. I have more negatives, so this is going to be negative 2x squared. And then I have a positive 6x and a negative 8x. The signs are different, so I subtract 8 minus 6 is 2, but I have more negatives, so it's a negative 2x. And x squared is a different term than x. The signs are different. They're a different variable part, so I can't combine this any further, and that's as simple as I can make it. Now, check out this one. This is where you might make use of like terms if you want to simplify a math expression. So I have 5x minus 8x plus 3y minus 5y plus 5. And I'm going to simplify and then solve this if x equals 2 and y equals negative 1. So I'm going to combine my 5x and my negative 8x. The signs are different, so I subtract 8, take away 5 is 3. But I have more negatives, and it's negative 3x. So I simplified those. Now this is 3y minus 1y. The signs are different, so I subtract. 3 minus 1 is 2. And I have more positives than negatives, so positive 2y. Now look at this. I also have a plus 5. That does not have a variable part, so we can't combine it with the others. We can just keep it separate. And remember, this brings up another algebra term. If a number has no variable part, we call that guy a constant. So that's as simple as we can make this math expression. We can't combine the 5 with the y or the x because it doesn't share the same variable part. But what I can do now is solve this expression by substituting in these values for x and y. So I'm going to work down the page, equals negative 3. I'm going to replace the x with 2. This means negative 3 multiplied by 2 plus 2 multiplied by negative 1, because y is negative 1, plus 5. To solve this, I have to do the multiplies first, right? Negative 3 times 2 is negative 6. And 2 times negative 1 is negative 2 plus 5. Keep working down the page. Negative 6 and negative 2 combines to negative 8. And I still have a plus 5. And then negative 8 and positive 5, the signs are different, so I subtract. And I have more negatives. That makes negative 3. So that's how you can use like terms to simplify a math expression, and then use the idea of substitution to solve that math expression. That's a little lesson on like terms, kids. I hope that helps with today's activity. I'm going to get you to practice some work with like terms today. That's all for now. Flexing Teacher Weber, out.